In this video, we're going to look at some formulas for integrals involving sine and cosine. And these integrals are called orthogonality relations. And basically, orthogonality is, in the context of vectors, it's when the dot product of two vectors is 0. And we'll see that the integrals we find, a lot of them will be 0. And vaguely speaking, because of that, they're called orthogonality relations. So the first one is the integral from negative L to L, and L is some positive number, of sine of k pi x over L, and k here is an integer. K is an integer. Well, this is actually an odd function. Sine of k pi x over L is an odd function. And we know that when you integrate an odd function from negative L to L, you get 0. So the integral is 0. Okay? Why is this an odd function? Because if you replace because if you replace x by negative x, you get a negative here. And there's the odd property of sine, that when you have sine of negative theta, so then this k pi x over L would be like your theta. So you have a sine of negative theta, that's equal to negative sine of theta. So that's k pi x over L. And that shows that this function is an odd function. Okay. So you get 0. Then the second integral is the integral from negative L to L of cosine of k pi x over L. Now in this case, if there are actually two cases. If k is 0, then what this is equal to is the integral from negative L to L of cosine of 0. Well, cosine of 0 is 1. And so the integral is just 2L, because it's just L minus negative L is 2L. On the other hand, if k is not 0, then to evaluate this integral, you can use substitution. So you could let u be k pi x over L and then do a substitution. Or you can, if you can easily do this, you can rewrite this as L over k pi times sine of k pi x over L. That would be the antiderivative from negative L to L. Okay. So here we're just using the fact that when you do an integration, like if you have the integral of, cosine of like ax or something, this is just going to be 1 over a sine of ax, right? Plus c. That's just from doing the u substitution. So when you have a substitution where it's just u equals a constant times x, then it's actually pretty easy to see how to do the integral. So now you have this, and then this is going to be L over k pi times sine of, well, you substitute x equals L, so you're going to get k pi, and then minus sine of negative k pi. Well, k pi, if k is an integer, then k pi is a multiple of pi, and so sine is going to be 0. And so you're just going to get 0. So if k is not 0, this integral is just 0. So this integral is 2L if k is 0 and is 0 if k is not 0. That's what we found. Whereas the integral above is just always 0 no matter what the value of k is. So let's write this down. So we have this one and we have this one. These integrals are going to be important when we're talking about Fourier series. Okay, so these are the first two. Those are pretty basic. Then the third one is also pretty basic because you have the integral from negative L to L of sine m pi x over L times cosine n pi x over L dx. And m and n are integers that are greater than or equal to 1. Well, here, so we went over the fact that sine of m pi x over L, that's an odd function. And similarly, cosine of n pi x over L is an even function. Okay, I'm just going to write out how to quickly check that this is an even function. So cosine of n pi x over L is an even function because when you replace x by negative x, okay, so this is going to be cosine of negative n pi x over L. I just take the cosine, well, I just take the minus sign out, but it's still inside the parentheses. And then we use the same idea that if you take n pi x over L to be theta, cosine of negative theta is equal to cosine of theta. That's a property of cosine. And so you're just going to get cosine of n pi x over L. So when you replace x by negative x, you actually get the same function. So that means that you have an even function. And we know that the odd function, so I have an odd function here, okay, times an even function. So the product of an odd function with an even function is an odd function. And so what is the integral? It's 0. Okay? So that's the third property, the third integral that we're looking at. That this integral of a product of sine and cosine, sine of m pi x over L times cosine of n pi x over L, that the integral from negative L to L is 0. Okay. And now we're going to look at what happens when you have sine times sine and cosine times cosine. So those are the last two we're going to look at. So now we're going to figure out the integral from negative L to L of sine of m pi x over L times sine of n pi x over L. Well, in the previous video, we went over this product to sum formula. And there's a formula for the product of two sines, sine ax times sine bx. And I'm just going to use the formula here. And when you use the formula, you end up getting, okay, so you replace this product of sine using the product to sum formula. Use the product to sum formula. And then you're going to get a sum, and then you can split up the integral. And when you do that, you get 1/2 outside. Okay, it's because you have something divided by 2. So I just wrote it as 1/2 times. The integral from negative L to L of cosine of m minus n pi x over L minus the integral from negative L to L of cosine of m plus n pi x over L. Now let's say that m is not equal to n. Well, now we see that we have an integral of cosine. By the way, you usually don't have to write parentheses when you have cosine, but I'm just going to write it like this. So if m is not equal to n, then you get cosine of some integer pi x over L. Right? So my m minus n would be like my k here. So when you have this integral, we went over the fact that it's going to be if k is not 0, then this integral is just 0, right? So, and similarly on the right, if you take k to be m plus n, then you get 0 if m is not equal to n. And m and n, again, are positive integers. So if m is not equal to n, then you just get 0. And this whole integral is 0. On the other hand, if m is equal to n, then what we end up getting is 1/2 times the integral from negative L to L. So then you would just get 0. So you get cosine of 0 is 1. And then minus the integral from negative L to L. Well, this thing here, okay, it's going to be 0, right? So this part is 0 for the same reason as above. And so we just get 1/2 times this integral of 1. Well, that's equal to 1/2 times 2L. And so that's just equal to L. So this integral is equal to 0 if m is not equal to n, and L if m equals n. Now there's one more integral, which is when you have cosine times cosine. So the last one is the integral from negative L to L of cosine of m pi x over L times cosine of n pi x over L. Again, m and n are positive integers, and we're going to use the product to sum formula again. So this is going to be 1/2 times the integral from negative L to L of cosine of m minus n pi x over L dx plus the integral from negative L to L of cosine of m plus n pi x over L. Is that true? Hopefully this is true. I'm pretty sure this is correct. Okay. So if m is not equal to n, then we just get the same as before. This is equal to L. If m is equal to n, then by the same calculation as above, we get L. So this is going to be 0 if m is not n, and L if m is equal to n. So these are these basic trig facts, and they'll be used in calculating the Fourier coefficients, which we'll talk about in the next video.